Some other considerations that we need to take when we design the address allocation for the different networks or subnets include how to prevent the duplicate addresses. So we need to make sure that all the host addresses are unique and no hosts on two different subnets are assigned a different address. And that's why we need to document and plan the address ranges carefully in order to make sure that the addresses are unique. Also providing different control and access schemes. For example, if you have different servers on some of the subnets, you need to make sure that these servers, they would have static IP addresses because they need to be exposed and accessed from outside. Also other peripherals like printers, which can be accessible from other subnets or another parts of the network or not. So all these factors, they affect the way that we design the different addresses of the hosts. Also, how to control the security and performance of the network. As we said, if we divide the network into large broadcast domains, this will affect the security issues of this network, and also will create some kind of overhead in terms of a lot of broadcast traffic on the network, which is not necessary. So in that case, we need to assign some address ranges for clients, for host clients, and this address range can be assigned dynamically by using a DHCP server. Some of the servers, they need to be assigned fixed IP addresses, and also we assign some address ranges for that. Some of the printers, whether these printers are accessible from outside or not, this affects the fact that we can assign static IP addresses or not, and the rest will be assigned for other network devices. All right, so the last part of this chapter talks about subnetting an IP address version 6 network. As we have mentioned before, that the IP address version 6 is typically divided into two parts. Each part is 64 bits, and the first 64 bits is assigned to the network part, and the last 64 bits are assigned for the interface ID. So for subnetting, we can actually divide the network part into two networks. There is a global routing prefix part for the network, and we have another 16 bits for the subnet ID. 16 bits, this will give us 4 different hexadecimal digits, and this can be used for subnet ID, and we call this a nibble. So a nibble is actually 4 different hexadecimal digits. So in that case, this 16 bits will give us 2 to the power 16 different subnets, and that's a huge number. And here, the only reason for subnetting is just to create some kind of a hierarchy in the organization. It's not to use like variable length subnet mask to save the number of addresses allocated or something, because here the address domain is huge. The only reason for subnetting is just to create a logical hierarchy in the organization to divide the network into subnets. So these 4 digits, 4 hexadecimal digits, can give us many different subnets that we can select from. So, for example, if we have a network that looks like this, so here we have 1, 2, 3, 4, and 5 different subnets. So in that case, we can use that subnetwork ID and use any 5 subnets, as we can see here. So the first 46 different network prefixes will stay the same, and the subnetwork ID we can set it from 0 all the way to 4Fs, and this will give us a huge number of subnetworks that we can select any of these 5 subnets to be assigned for the different subnets. Assign these different addresses like 1, 2, 3, 4, 5, and then we can configure this accordingly on the router using the commands on the router. Another further subnetting can be done by borrowing one digit from the interface ID. So we can subdivide some of these subnets using 4 bits borrowed from the interface ID. So instead of using only 64, we can use another 4 binary bits or 1 hexadecimal digit, and this will include, or this will make the network part as 68 different bits for the network part, and in that case this will be only 60 bits for the interface ID. Again, the subnetting for IP version 6 is much easier because, again, we don't have to use the dot decimal notation. Here we use hexadecimal, which corresponds to binary bits right away. So we can borrow like 4 bits here, and starting from 0 all the way to F, which will give us different variations of subnet that we can select from. That's the end of this chapter. In this chapter, we talked about subnetting. So we talked about the reasons for subnetting a network is to create a hierarchy and save the address space for the IP version 4. We talked about the basic subnetting. We talked about variable length subnet mask, where we can subdivide the network on 2 stages or 3 stages, depending on the structure or the architecture of building or the organization that we're planning the address allocation for. We also talked about the different considerations for subnetting, including the prevention for the duplicate ID, the different servers or different peripherals that we need to be accessed from outside, and last but not least, we talked about subnetting IP address version 6, and the fact that subnetting for IP address version 6 is much easier because we only need to create some logical architecture or logical hierarchy for the organization, and in that case, using hexadecimal can make the job easier for subnetting, as we have seen.